Hello, my name is Kane Greenough. I work for Morgan Sindall Construction and I'm the Senior Sustainability Manager for our construction business. I'm going to go through the presentation, managing carbon in construction, and hopefully put things into very simple terms. So topics we're going to discuss is what do we measure as a business, life cycle assessments and EPDs and carbon measurement tools, managing carbon in construction, so how do we actually do this, and how the supply chain can actually help with our carbon targets and our carbon management. So what do we measure as a business? So at Morgan Sindall, we have set a target to be net zero by 2030, and that's reducing our scopes 1, 2 and site operational scope 3 emissions by 65% by 2030 against a 2020 baseline. By 2045, we want to be net zero across all scopes with no offsetting, whilst the 2030 target does include offsetting, which I'll cover in a second. So what are scope emissions? So from a site perspective, scope 1 is direct purchases such as direct fuel. Scope 2, again, from a site perspective, is the electricity that we use. And scope 3 is everything else. Now, our operational scope 3 emissions that we include for our 2030 target includes waste, includes subcontractors' fuel, and obviously, but we don't actually cover all the scope 3 emissions, but that's what we will pick up in our 2045 target. However, we do measure scope 3 emissions through the tools, which we'll explain in a short period of time. So these are our national KPIs. So we measure waste by tonnes per 100k of spend based on project value. And you can see there in 2023, we were at 1.28 tonnes. We dropped it down to 2024 at 1.13, but we did pick it back up to 2025 by 1.28 because we have flatlined as a business around the 1.6 mark. So we do need to obviously help from our consultants to start designing out waste at source. The net zero trajectory is measured as kilograms per CO2e per 100k of turnover, and that picks up what's happening in the site offices and also the offices occupied in like the Newcastle office. Low carbon sites affects net zero trajectory. So low carbon sites affects what's happening on site. And again, it's measured by kilograms per CO2e per 100k spend. And you can see that number is reducing every year from 2023 to 2025 and all the way up to 2030. That's going to keep dropping. So low carbon sites picks up the electricity we use and the fuel we use, including subcontractors' fuel. Now, obviously, to get to 2030 and be net zero at 2030, we're offsetting. We've already started this. So in the Blenheim estate, we've planted 270,000 trees of mixed tree plantation across 28 different species. And that will help us to obviously get to our 2030 net zero target. Again, at Lake and Heath, which is the RSPB for the habitat of birds, we expanded that natural habitat by 54 hectares, equivalent to 81 football pitches, which helps with biodiversity, it helps with sequestering carbon. And in the Great North Bog, you wouldn't have thought this would be a problem, but we're trying to keep the Great North Bog wet. Because what's trapped in the ground in the Great North Bog is methane, and methane is classed as 28 times more potent than 1 CO2e. So we need to make sure that it's kept in the ground and it's not released. So obviously, in terms of all these, this is helping us to get to net zero. It's all in the UK. It's measurable. We can go and see it. It's not somewhere in the world and somebody's taking a picture of a tree and showing that same tree to another 10 companies saying that's your tree and we can't prove it. So I'm going to talk about life cycle assessments and EPDs. But to do that, I'm going to obviously use the extract from the RICS Professional Standard 2nd edition. So this is how we measure buildings. This is how we measure products. So they follow gateways. So you can see the gateways there. A0 is that's surveys typically. But A1 is raw materials coming into a factory. A2 is the transport of the raw materials to that factory, and A3 is making that product. Now, when that product is made at the factory gate, A4 is transport, but we need to measure transport from the actual factory through to the actual site itself, which you can imagine will be quite challenging when a lot of the products do come from Europe. A5 is what we do, so that's the building, and that's obviously the scopes 1, 2, and the site operational emissions that we've just discussed. Now, imagine now that we've handed over that building to a client, and the B stages is replacements, it's maintenance, but everything above that dotted line, just below upfront biogenic carbon, is called embodied carbon. Everything below that line, you can see the B6 and B7, is operational carbon. So operational carbon picks up the energy used by that building for the next 60 years. The embodied carbon is the materials that we use, it's the replacements, it's the energy we use to create a building. And then at the end of life, the C stages or gateways follow. So that includes decommissioning, deconstruction and disposal. And outside the box is the D, so that's circular economy, which is coming, and it's key to us decarbonising the construction industry. But circular economy, the reason it's outside the box, because it can be applied at the A stages, so on site. When we're getting waste, construction waste, circular economy can apply then, such as cradle to cradle schemes or reuse. It can certainly apply through the B stages, because obviously when you've got maintenance replacements, again, some of these products can go back to manufacturers to be recycled into new products, or we could reuse products. Do they have to actually go to landfill? And they can apply to the C stages. So we come to demolish that building. And again, we take that building apart, and can these products be reused or recycled? But what you can see there on the right-hand side is that majority of the carbon is trapped in the products. And it's trapped in the early stages, the A1 to A3 process. So it's the manufacturing process. So 50% of the total whole life carbon of a building is materials. And it's upfront materials made at the factory. Transport amounts for a small amount of carbon, and that's picked up A4, and that's around 4% according to the RICS. However, this is because we don't have a lot of data on transport, because there is no Google Maps out there that typically we can follow from a factory. Say steel is made in a factory in Oliveira in Spain. It goes by a road route, then through to the sea. Then is picked up by a ship. It goes along the sea routes, then to the UK. It's picked up in the port, and then it goes to a stockist, and it goes from a stockist then to a fabricator, and a fabricator to site. There's different methods of transport, and there's different distances, but that's how we should be measuring carbon. But I think the reason that 4% is so low at the moment is because we've got no real way of tracking this other than physically trying to measure it. 1% is what we do. So that's the scopes 1, 2 and operational scope 3. We also need to consider the service life of products that we're selecting, which are picked up in the B stages. So how long does a product last before it needs to be replaced? And this again is picked up from the same RICS extraction or publication. But what you're seeing there on the left-hand side is a building regulation compliant building with gas heating. The top bit at the top, the lighter colour, that's operational carbon. The middle bit is the B stages, that's embodied carbon, but that's replacements and maintenance and materials. And the darker colour at the bottom is the upfront carbon. So that's the A0 to A5 carbon number. And most of that is materials, the manufacturing materials. The middle bar you can see there, that's actually from that's a typical building excluding gas, so it's just electric heating building. But there you can see there's a significant proportion of carbon is in the materials, which is the colours at the bottom. So it's the darker colour and the middle colour is all materials. And the one on the right hand side is passive house type buildings. So again, you can see there's a significant proportion of whole life carbon is in the material selection. So it's not only should we be looking at the operational carbon, which helps with the running cost of the buildings, but we also need to look at materials. Hence, that's why we need to consider whole life carbon and not just one or the other. So we've got measurement tools to do this. We've got our very own in-house whole life carbon calculator called Carbonica. And we have our embodied carbon library to aid with product comparisons. So what type of steel, even though it looks like steel section, which is the better one, and from which mill. Carbonica is a digital construction tool that measures the whole life carbon assessment and carbon emissions, ensuring potential carbon outputs can be managed and reduced during design, procurement, construction, and the entire building life cycle. This is an extract of Carbonica, and this is all embodied carbon. But what you can see is the dark green bit is materials used in the construction process, and the orange bit is the actual replacements. It's the maintenance, it's the end of life. But what you can see typically here straight away is we should be looking at the foundations, the frame, we should be looking at the mechanical, electrical. Floor finishes also presents a problem for us, upper floors does, but this again helps us to identify where are the focus areas to help us to reduce carbon. So we don't need to look at everything, but we do need to focus on these key areas that obviously are contributing the most to the embodied carbon in the building. So how do we measure carbon in construction? Well, early engagement. So early client engagement is essential. So let's look at focusing on carbon. How can we reduce waste? How can we improve circular economy? And we can only do that by early engagement and getting involved in design. This is like money now, so we create a baseline model. So once we've established a carbon model, that becomes a baseline model. That's something for us to follow. That's a pot of money, or you could say carbon allowance that we do not need, that we do not want to exceed. We copy that model and create an as-built model, but the difference is with the as-built model is we actually update that with live data from the marketplace. So that's data from manufacturers, such as EPDs and LCA information of how they measure carbon in their products. And we also market that in the 10-ton challenge. So when we're making carbon savings against the foundations, against the piling, against the frame, we also create a 10-ton challenge, which is a case study demonstrating what we can do within our buildings, and we showcase that and share that with the rest of our business. And at the end of the project, at project completion, we actually put in the construction waste, site electricity, fuel and water consumed into the as-built model. So you've got a final product. Supply chain engagement. So we can't do this alone. Most of the products come via our supply chain. We don't buy a lot of materials direct. So again, our supply chain should be helping us to decarbonise our buildings. They should get closer to the manufacturers, understand what they can really offer, and that will in turn help us by them giving us good early advice. Again, early supply chain commitment. So what can the supply chain do to help decarbonise our buildings from the baseline model to create a good as-built model? So can they promise a certain percentage of electric arc furnace steel, which is made from about 98% recycled steel, versus basic oxygen furnace, which is typically blast furnace steel. It's very heavy in carbon. So can they promise more of the electric arc furnace steel compared to blast furnace steel to help us to decarbonise that building? Product carbon numbers. We should no longer compare just price and specification. Competitive carbon is coming, so we should also look at comparing products against the carbon values of products. So for instance, when we're looking at different concrete mixes, it's not just the price of the concrete mix, it's also the carbon values associated with that concrete mix to make sure we're buying as competitively and optimizing our design as much as possible. On-site operations. So again, we need commitments from our design, our supply chain to make sure that they're being diesel free. So that could be a hydrogen plant, electrified plant, or moving to biodiesel such as HVO fuel, but we do insist on sustainably sourced palm oil free biodiesel. And construction waste. So how can they help us to reduce our upfront carbon number by reducing the amount of construction waste coming to site? Again, the installers, the supply chain can help us. They install these products and it'll help save them money if they really understand this as well. Responsible procurement. So what we are rolling out across the business is called responsible procurement. So we're actually asking our supply chain to measure the scopes 1 and 2 emissions, set clear business targets and future targets to decarbonise their buildings. The beauty about that, if they go to the supply chain sustainability school, this is a free tool that they can use to obviously work out their scope 1 and 2 emissions. Understand scope 3, so speak to the manufacturers, understand the embodied carbon that's in the materials that they're supplying to site. What can they do that that is better? What are the manufacturers doing that is going to give us that that edge to not only win work but to decarbonize our buildings? And if they can, the supply chain can measure themselves against their own carbon maturity framework, which will show. So you can see the level 1 is upskilling. So that's simply upskilling your own staff, and that could be going again to the supply chain sustainability school. And there's a whole raft of information on the education information that helps you upskill your own staff, and it's free. Level 2, again, using the supply chain sustainability school, you can measure your own emissions, your scopes 1 and 2. And again, understand where you're up to, prorate those emissions based on turnover like we've done. And then what you can do is set targets for like as simple as 2030 and look at reducing your current emissions or your current target by 10% every year to 2030. Look at offsetting, you can do, you don't have to, but certainly at least get onto this ladder of measuring carbon, understanding it and reducing your own emissions. Level 3 is transparency. So level 3 is actually going to the Cambridge the Cambridge network, and they have different methods of transparency. And level 4 is again, it's the Cambridge way of measuring carbon, and that is picked up. I think it's platinum, and level 5 might be silver. Sorry, there it is. So yeah, so what you can see, the level 3 is carbon reduction code, which again is the Cambridge carbon reduction code. That's the pledge process. Pledge status. The signatory status is level 4, so that's a bit more onerous. Again, the carbon reduction code, you can get on there from the Cambridge carbon reduction code, and the champion status is the optimal status that we're asking on this journey. And that's it. Thank you for listening.